And welcome back again, Geometry. We are back for Chapter 12, Day 6. This day is all about arcs and angles. Okay, so we're looking at angle answers. We're going to be intersecting a bunch of lines. So either chords running into each other or secants or tangents running into each other and looking at the angles that get cut off. So there's a bunch of different possibilities. So there's a couple pictures here that you can see. Okay. Sometimes these lines intersect inside the circle, okay? And what happens with that, if they intersect on the inside, so for example, there's an arc here and here that get cut off for these two angles, and there's a relationship there, but there's also a relationship here with these two angles, and then these arcs that happen. So they could be inside the circle, they could intersect right on the circle like that, okay, and then there's an angle between, or a relationship between this angle and this arc that we're going to explore, or they could intersect just outside of the circle, okay, and when that happens, okay, there's a relationship between this arc and this arc, and we'll have to look at that one too. So those are kind of the ideas we'll look at today. We'll get some formulas for it. We'll get some examples. We're going to do for day 6, we're not going to have any algebra. And then the day 7 notes will have algebra, same pictures, but with algebra. So today we're just going to have number answers. All right, here we go. So if we have first inside intersections, so interior intersections, if two secants or chords intersect inside a circle, then the measure of the angle formed is equal to half the sum of the measures of the intercepted arcs. So that seems important. Okay, they put it in bold type. So what that means, okay, so if we're intersecting inside of the circle, okay, we have this half the sum of the intercepted arcs thing. So here's my two chords in this picture intersecting. They intersect inside the circle right there. They're hitting each other inside the circle. What that means, okay, the measure of this angle right here, angle 1, okay, which is going to be the same as this side, vertical angles, okay, those angles right there, angle 1 is going to equal, okay, 1/2 of the two arcs that are formed by those. So what does that mean? It's half of this arc plus this arc. Okay, so 1/2 of the measure of arc AD plus the measure of arc BC. Okay, it works for angle 2 as well. Okay, this angle, angle 2, is going to be equal to 1/2 of this angle, so this arc, arc AB, plus this other arc, DC. So inside intersections, they kind of form two sets of arcs, and the angle on the inside is equal to half of the two arcs added together on the outside. So that's a little bit about how it works. Okay, I think some examples will help with this. So if I want to figure out the measure of angle AED, for example, number 1, that's going to be right here. So AED is this angle. They want this angle right here. Okay, it's not on the center, so it's not 45. If this E was on the center, it would be whatever this angle is, okay, or whatever degree measure that is. Since we're not on the center, this one works a little bit differently. Okay, we have to look at these two lines. Okay, we want to get this angle. Okay, this angle is going to be equal to 1/2 of the two arcs that are formed by those lines crossing. So that would be this 45 and this 109. And 1/2 of 45 plus 109. So this is how it works when chords intersect. This is 1/2 of 154, okay, which is just 77 degrees. So either side of angle E right there would be 77. Okay, STR, okay, that's this angle. STR, they want this in the middle, okay? It's across from a 112. The other side of that angle, okay, would be right here. These two would be the same amount of degrees. Would be that's across from a 186. So I need to add those two together and cut it in half. So that's going to equal 1/2 of 112 plus 186. This is 1/2 of 298, okay, which is 149 degrees. All right. So we just have to be careful, make sure that we're reading carefully about what they're actually asking for. But if you see two lines intersect like that inside the circle, we have this half of the arcs thing, okay? YWX, that's this one. So this is a little bit tricky, like I was just saying. Okay, this is YWX, okay? So it's half of this arc, okay, and this arc, the ones opposite of each other. Okay, so that one's a little bit trickier. What we can do is we could figure out maybe what those arcs are using 360, but that's going to be a little bit tough. I don't think we have quite enough information for that. What we can do first is figure out this angle, okay? Because this angle plus the one we want, this is the one we ultimately want right here, okay? We want that red angle. If we can get the blue angle is going to be supplementary to the red angle because they're a linear pair. So I could figure out this blue angle first, okay? So the first thing I'm going to get is the measure of angle. Let's call that one VWY, the blue one. That's 1/2 of the two arcs added together. So that would be 43 and 81. So 43 plus 81. Okay, so that's 1/2 of 124, which is 62. Okay, that's not the answer for what we want, but let me show you what we just got right here. We just figured out that this is 62. Okay, and what we want is this angle that's right next to the 62. So the measure of angle YWX is going to be 180 minus 62, since that is a linear pair. So this is 118. Okay, this one they're asking for an arc instead of a angle measure, so that we want a measurement on the outside. So LK, this is what we're interested in. Okay, what we know is that LK plus this arc divided by 2, if I add those two together and divide by 2, that gives me 62. So here's what I know. 62 is equal to 1/2 of those two green arcs added together. Let me just call this X for now. Okay, X plus 74. I can solve that for X. The easiest route is to just double both sides to cancel this 1/2. So if you double both sides, you get 124, and now the 1/2 is gone. So we have X plus 74. And once you subtract by 74, you get that 50 is equal to X, and that's equal to our arc LK. So that one was working backwards. Same thing with number 5, very similarly, we're working backwards again. So CDE on this one. So CDE is the arc right here. Okay, they want us to find that arc. So it's related to this other arc right here, 73, okay, and it's related to this 128 number. Okay, we know that 128 is the inside angle. That's equal to 1/2 of the arcs added together. So let's call this X again, X plus 73. Okay, when you double both sides again, we get 256 equal to X plus 73. And subtract 73, we get 183 degrees for X. If you get a big number like that, make sure it makes sense. But this is the arc we're looking at. It looks like it's more than half the circle. So 183 seems reasonable. Okay. Number 6, same type of idea. Okay, we have one little trick first. They want the measure of arc QT. We'll mark that arc, highlight it. Okay, it's related to this angle. Okay, and this arc. Okay, well, we don't know that angle technically, but if this is 79, then this has to be 101 because these two make that linear pair. So we know that's 101. Okay, 101 is equal to 1/2 of, so this is my X this time, X plus 95. double both sides and get 202. This is equal to x plus 95, and subtract 95 from both sides. You'll get that 107 is equal to x, 107 degrees. All right, next type of picture. So that was with two chords intersecting inside, two chords or two secants. If the intersection is now on the circle, okay, it still has this half idea, okay, but there's not things that you got to add together. So if we intersect at the point of tangency or on the circle, if we intersect on the circle, angle 1 right here, okay, is just equal to 1/2 the measure of the arc it intercepts. So 1/2 for this one, this is the arc I'm intercepting right there, AB. 1/2 times the measure of AB. Okay. The angle 2 right here, okay, those lines intersect on the circle. Okay, that angle 2 is intercepting this entire arc right here, BCA, okay, or ACB, either way you want to say it. This is 1/2 of that arc, the black arc there, the measure of BCA. So it's still 1/2, but we don't have to add anything together. So finding each measure here, okay, they want DEG, that's this angle. Always trace what they're asking for. Okay, that's going to be half of the arc that it intercepts. So it starts at G, the arc starts at G and goes all the way around to E here, which is 308 degrees. So this one is just 1/2 of 308. Okay, which is 154. So the angle on the inside is 154 degrees. Okay, DBC, okay, let's trace that. So DBC is right here. We want that angle. Okay, we know that that angle is half of some arc. Okay, the arc that it's half of is right here, but we don't know that number. Okay, but we do know that the other arc is 192. We know that all the way around a circle is 360. So just off to the side, 360 minus 192. Okay, that's going to equal 168. And I'm just going to divide that by 2. Okay, to figure that out. So 1/2 of 168. That's what this problem is. So the green angle, excuse me again, is 84. Half of 168. Okay, a couple more examples that are similar. Okay, trace the one that they want. Now they're asking for an arc. So they're asking for how many degrees XY is. That's this little sliver right there. Okay, so that's what they're asking for. We can figure out the rest of the circle and subtract from 360. So the green arc is this 151 times 2, okay? It's because the inside angle is half as big as the arc. So we know that this entire arc is 302 degrees. So I can get the blue one, okay, by doing 360 minus 302. That's going to be the easiest way to do that. So 58 degrees would have to be this one. Okay, all the way around the circle is still 100 or 360 degrees. Okay, let's trace the one they asked for. That this time would be KNM, the arc KNM. So here to here, all the way around. We got to figure out all that stuff. So the first thing I would look at is, do we know this angle? And no, we don't. Okay, we don't know that angle, but we know that this inside piece is 23. That's this angle right here. So that's 23, okay, which means, this picture's a little bit small, but that means that this blue arc is 23 times 2. So this is 46. The blue piece is 46. So I need to look at subtracting from 360. 360 minus 46. That's going to give us 314. The other thing we could have done was use linear pairs. So if we had a 23 on the inside, we could have figured out what this angle was right here. We could have figured that out and then doubled it. Maybe we'll do that. If this is 23, okay, then 180 minus 23, that would give us 157, okay? So 157 would be that angle, and if you do that times 2, you get the same answer. So these ones might have more than one strategy. Okay, last type of picture, and then tomorrow we'll come back Okay, and then we'll put the angles back into it. Okay, but we have lots of examples of this next one here. So it's the last situation, but it's kind of three different pictures that it could look like. You could have two secants running into each other. You could have secant and tangent, or you could have two tangents. So those are the three pictures. The good news is, even though it can look three different ways, they all have the same idea. Okay, if we're meeting on the outside, so the lines are now intersecting outside the circle, okay, what we're doing is still this 1/2 piece, but 1/2 the difference. Now we're subtracting. So 1/2 of big minus little is one way to write it. So the angle is going to be 1/2 the big arc minus the little arc. Okay, that's basically the formula. Okay, so big arc, 1/2 of big arc minus little arc. So we can write that these ways here. So in this picture, the big arc is CE. So 1/2 of the measure of the big arc was CE minus the little arc is BD. Okay, that's going to give us the angle on the outside. So that outside angle is always 1/2 big arc minus little arc. So if it's a secant and a tangent, same thing. The big arc is here, BD. So arc BD minus, I'm going to give myself a little more space, the measure of arc, the little arc, BC or CB, doesn't matter. Okay, if it is two tangents, same thing. So the outside angle is equal to 1/2 the big arc, which is BDC, minus the little arc, which I'll just leave black for that, otherwise it'll look like the whole thing is shaded in, BC. They all say exactly the same thing. That's the good news. They're all saying big arc minus little arc. That's what every single one of these is saying. Okay, let's try some examples. So they want KLM, that's this outside angle. Okay, so the outside angle is equal to 1/2 of the big arc minus the little arc, 140 minus 66. So if it's on the outside, that's the time when we subtract. Okay, if they meet on the inside, we add. If they meet on the outside, we subtract. This is equal to 1/2 of 74. So this angle on the outside is 37 degrees. Okay, BCD, let's find that. That's again the outside angle. So if they're asking for an angle measure on these, it's probably the outside angle. That's going to be the only thing it can really be. This is 1/2 of 67 minus, and then we have, okay, we don't know this in this little arc right here, okay, but we kind of do. So we know that these three right here need to make 180 because we have a semicircle. So we could do 180 minus 94 minus 67. That's going to give us that green angle, okay? And this time that gives us 19. So 19 is this arc right here, okay? 19 degrees. So that's this inside angle using 180. 1/2 of 67 minus 19, that's 1/2 of 48. So that's a 24-degree angle on the outside. So they have little ways to make these a little bit more challenging, okay? Same examples on the next page, continued. So SW, now they're asking for the arc. So they want the big arc, okay? Make sure we put that in the right spot. The little arc is 75, the outside angle is 40. So we know that 40, so this is my X this time. 40 is equal to 1/2. We got to put the big arc first, so that's X this time. X minus 75. Again, easiest thing you can probably do is just double both sides from there. That'll give us 80 is equal to X minus 75, and then we want to add 75 to both sides. So 155 is going to be X. So the big arc is 155 degrees. Okay, QU, same type of problem. The outside angle is 35. The little arc is 46. The big arc is our X. Okay, so we know that 35, the outside angle, is equal to 1/2 of big minus little. That's X minus 46. Double both sides. We have 70 equal to X minus 46. add 46 to both sides. 116 is equal to x. 116 degrees for that big arc. Okay, this one's back to asking for the outside angle. Okay, so this one doesn't really have anything different about it. Okay, we have, this is the angle we want. Okay, we know that this is 33. We know that this is 135. So we're just going to subtract those. 1/2 of big minus little. 135 minus 33. This is 1/2 of 102. So our answer is 51 degrees. Okay. A, B, C on the outside. Okay, so we're looking for this angle right here, ABC. We want that. Okay, it's related to this little arc and this big arc. Okay, we know. So what we know is we have 1/2 of big minus little is 62. We got to get the big piece. So we got to figure out how many degrees this is, right there. Okay, well, I can use 360 for that. Okay, so if I know that this is 62 and this is 88, okay, I could add those together, but really I got to figure out this one by doing 360 minus, so 88 and 62 added together would be, that would just be 150. Okay, these two added together, so this is going to be 210. Okay, so 210 is the big arc. Okay, so we have 1/2 of 210 minus 62, that's 148, and that's going to give us 74 degrees. And like I said, little ways that they can make these a little more challenging. Okay, EF, that's the arc that they want this time, which is right here. Okay, so what I can do is I can figure out, if I can figure out this piece, then I know that the green and the red and the blue need to make 360. So let's just focus on finding the red first. So the red one is the little one. So this is like X right now, and this can be like Y in a second. Okay? So we want to end up finding Y. So to get X, okay, we know that 77 is the outside angle. So 77 is equal to 1/2 of big minus little. So we need to put the blue one here. That's the big one. Okay, minus X. Okay, double both sides. That gives us 154 equals 191 minus X. Okay, you could subtract 191 from both sides. You get negative 37 equals negative X. That just means 37 equals X. Okay, that's not the answer that they want, but if this is 37, okay, let me redo that. If that's 37, now we can use 360 to find the last thing that we need. All right, it doesn't seem to want to go away, but that's all right. So this is going to be a 37. Okay, so to get Y, okay, now I'm going to try to get Y. So 360 minus 191 minus 37, that's going to give me Y. Okay, so Y is going to have to be 132. Okay, just a couple of them left. So looking through, these ones are going to be, this one's going to be very similar. 18 is the same exact type of idea, but it's probably good to look at that negative X thing one more time. All right, so we're going to find MK. So this is our X, okay? That's the little arc. What we're looking for is the little arc. So the outside angle is 56. That's equal to 1/2 the big arc of 160 minus the little arc, what we're looking for. When you double both sides, you get 112. When you subtract 160 over, you get negative 48 equals negative X. That just means 48 equals X. Okay, last two. These are two tangent lines now. Okay, same formula. Just two tangent lines. The picture just looks like it should be a little bit different. Okay, PQR, okay, they want this angle on the outside. Okay, well, we know that this big arc is 313. Okay, what that can tell us is this little arc. We can get this little arc right away with 360. This has to be 47. Those two numbers have to make 360 with tangent lines going all the way around. Okay, So with those, we have 1/2 of big minus little, 313 minus 47. Okay, this is equal to 1/2 of 266. So that's going to be 133. That's going to be my blue outside angle. All right, same thing, different problem. So we know the little arc is 106. If we know the little arc is 106, we know the big arc has to be whatever makes that 360. So that's going to be 254. Okay, we can use this information to find this outside angle. So this is equal to 1/2 of big minus little, okay, which is 1/2 of 148. So that's 74 degrees. And tomorrow we'll come back and we'll put the letters back in. We'll put the algebra back in. Okay, but for now, that's what we have. You're going to do about half of the assignment. So let me make sure that that's what we have here next. Nope, we don't, and that's okay. So you're going to do the first half of the assignment on worksheet 7, worksheet 6/7. You're going to do everything that doesn't have algebra in it. So that's going to be numbers 1 through 8. So your homework assignment is 1 through 8. All right, thanks for watching. Go ahead and give it a shot.